Hello and welcome to the next one. We're going to talk a little bit more about more complex statements here. It's going to be a little bit quicker because I've already gone over the basic structures. We're going to talk about things like and, or, is, and not. Little interesting things like that. First things first, when it comes to the is operator, it is a replacement for the double equals. Some people really like it. So you can say X is. It is a little bit more readable. If you've never seen code before, you can say if X is 5, and then you know that you're comparing, X and 5. Some of the other things that you can use are not. So in this case, it takes your Boolean values and inverts it. So for example, let's go ahead and print, I think true is a type. I might be wrong. Get my Python all mixed up. Yes, it is. Okay, good. All right, so I can say not true. It's gonna be false. Okay, there we go. So as you can see, what we're just saying is we're just saying not. In other languages, like for example Ruby, you just use an exclamation point, and that would invert the values. And so not is just an inversion value. So it's pretty good. You can compare things and you can not them. If you want to do logic in one direction and then you need to know the comparison in another direction. It's a little bit more complicated and we'll get into that later. But let's just go ahead and take a look at and or real quick. So what we're going to do is we're going to define a new variable. This is going to be y, and y is going to equal 1. And we're going to make x back to 5 our favorite value for x because that's what x belongs as. It identifies as a 5. In this case, y is going to be our number 1. And what we're going to do is we're going to say if x equals 5 and then we're going to use our y, and our y is going to equals 1. We're going to print both values are sound. Else, our favorite thing in the world, something is awry. Let's go ahead and run that. You'll see here, I say both values are sound because currently the values are right. Now, if we switch y to a 2, you'll notice that it says something is awry. Even though 5 is still x, both of these values have to be true. So both of these statements have to be true. In this case, I can flip this statement. So now we're asking if the variable x is 5 and the variable y is not a 1. In this case, both of these are true. We run it, we're going to get both values are sound. Let's actually get rid of some of these extra statements because we don't really need these right now. Let's go ahead and comment those out. So that's interesting and all, but let's go ahead and go a little deeper into this. Let's go ahead and switch to or. So or is a little bit more complicated for most people because even though the concept of or is very simple, red or blue, to us, that means both could be evaluated equally in kind of human logic. In computer logic, it's a little more strict than that. In that or is a very specific operation that cannot be confused with XOR, which I'm not going to go into. I'll probably cover it on a video one of these days. So we got here x equals 5, or if y, let's say equals 1. Okay, and then instead of saying both values are sound, it'll say we've passed. We've failed. Okay, so let's go ahead and look at that. It says we've passed. Now, why did we pass? First thing is x is 5. So that is true. Or means that either of these statements are true, we pass. It doesn't mean that we can selectively choose, per se, which value is true or false to pass. But it means that if either of them are true, it does not care. So it's a very simple, very easy structure. So don't get confused by it. So let's go ahead and make a more complex structure. I know. So we're going to say z equals 3. And then let's go ahead and set this to 1. And what we're going to say is we're going to say x equals 5 and y equals 1, or z equals 3. Let's start by hiding these so we don't get confused by outputs. And say we passed. All right, so we passed. So this is a true statement for us. It's pretty easy because we're evaluating these 3 values and all 3 of them have passed. But let's go ahead and mess this up a little. Let's change that. We've still passed. All right, well, let's change this. Now we failed. Okay, well, that's good and all, but our z is not equal and our 5 is. Our y is also not equal. So let's go ahead and pop this back to a 1. We're still passing. So how is this evaluated? This is evaluated actually pretty easily. And you can get far more complicated with some of these logic trees. Usually at this point, I would say this is a fine statement. It's easy to read. We can say if x is 5, and we're checking that value, and it's true, and y is 1. Currently, that is true as well. So both of those have to be true. That's one side of the tree. Or if z equals 9. Okay, so let's change z equals 9 to z equals 3. So this is true. We've passed. Now let's go over here and let's mess up y. You'll see that we've still passed. Now let's come over here and let's mess up x. We've still passed. So basically, well, the way this is structured is that it is comparing the ands as one. In a way, you can think of it as one statement, in that both of these will have to be true. But even if both of these are false, it will still be a true statement as long as this side of the tree is also true. So as long as z equals 3, we do not care at all the values of x or y. So I know it's a little drawn out, a little bit complicated, and a little bit rambly compared to most of what we've done so far. But I just wanted to kind of show you a little bit of that complex. If you've done any kind of computer programming whatsoever, this common stuff, most languages will interpret this exactly the exact same way. I just wanted to make sure that these were clear before we moved on to some of the more exciting stuff.